Clean architecture. What is this actually? It is a software architecture, proposed by Uncle Bob. Software architecture refers to the process of creating high-level structure of a software system. It is about the complete structure or architecture of the overall system, means it converts software characteristics like scalability, security, reusability, extensibility, modularity, maintainability, etc. into structured solutions to meet the business requirement. Let's understand the goal of software architecture. The goal of software architecture is to minimize the human resources required to build and maintain the required system. Remember that the software size will grow with time. It will add new features and remove the redundant features. It can change various components like database, user interface, etc. Multiple developer will work in this software. It can be testable properly. The development and maintenance costs should remain linear forever. Software architecture is needed to ensure these things. Let's see the clean architecture from a very high level. This schematic is proposed by Uncle Bob. But what the circles means, and what are the various terms here? An entity can be an object with methods, or it can be a set of data structures and functions. For example, this shows what a lone entity might look like. It has 3 pieces of critical business data and presents 3 related critical business rules at its interface. Use case, sometimes called interactors, defines actions the user can trigger. They implement the dataflow logic. It specifies the input to be provided by the user, the output to be returned to the user, and the processing steps involved in producing that output. This shows an example of a use case. Enterprise business rules. This is your business policy in real world. Let's imagine you want to start your startup, your business, it is food delivery. Then you think, it will have some features, like, apply discount for any user who is poor. Reward shipper if they work hard enough. So these ideas, if they come true, it will be your enterprise business rules. Application business rules. This is the features of your app, the total list that your app need to get done to be your app. It's like enterprise business rules, but it is specific for your application. For example, in our food delivery app, we can have some feature, like, get the user by email. Get some hot foods. Order food. The concentric circles represent different areas of software. In general, the further in you go, the higher level the software becomes. The outer circles are mechanisms. Inner circles are policies. The overriding rule that makes this architecture work is the dependency rule. This rule says that source code dependencies can only point inwards. Nothing in an inner circle can know anything at all about something in an outer circle. In particular, the name of something declared in an outer circle must not be mentioned by the code in the inner circle. That includes functions, classes, variables, or any other named software entity. By the same token, data formats used in an outer circle should not be used by an inner circle, especially if those formats are generated by a framework in an outer circle. We don't want anything in an outer circle to impact the inner circles. The dependency inversion principle states that high-level modules should not depend on low-level modules, both should depend on abstractions. Abstractions should not depend on details. Details should depend upon abstractions. Interface adapters. The software in this layer is a set of adapters that convert data from the format most convenient for the use cases and entities to the format most convenient for some external agency, such as the database or the web. It is this layer, for example, that will wholly contain the MVC architecture of a GUI. The presenters, views, and controllers all belong in here. The models are likely just data structures that are passed from the controllers to the use cases, and then back from the use cases to the presenters and views. Similarly, data is converted, in this layer, from the form, most convenient for entities and use cases, into the form, most convenient for whatever persistence framework is being used. For example, the database. No code, inward of this circle, should know anything at all about the database. If the database is a SQL database, then all the SQL should be restricted to this layer, and in particular to the parts of this layer that have to do with the database. Also in this layer, is any other adapter, necessary to convert data from some external form, such as an external service, to the internal form used by the use cases and entities. Frameworks and drivers. The outermost layer is generally composed of frameworks and tools, such as the database, the web framework, etc. Generally, you don't write much code in this layer, other than glue code that communicates to the next circle inwards. This layer is where all the details go. The web is a detail. The database is a detail. We keep these things on the outside, where they can do little harm. I understand, you are totally confused, and fully in the blind spot. Let's understand, with a real-world example. Suppose, we are developing a to-do app. And, we are adding a new task. When user will click Add button, the user interface will notify ViewModel that user wants to add a new task, and these are the data for that. The ViewModel will call use case with those data to create a new task. The use case will contact with tasks entity to do that. The tasks entity will command tasks repository to add a new task. The task repository will decide which resource to use as per the situation. The responses will be going back up to the ViewModel. The UI will follow the ViewModel states. But why we need so complex architecture where we could do it in very simple way in UI itself? If we do everything in UI, then the source code will be very big. After some time, it will be fully unmanageable. Only one developer can work, which will prevent timely release. To change a component, like database, network library, etc., it will be very painful. Let's justify the architecture used in our example Toto app. This is our UI part. This is data and business logic part. This is the bridge between them. So, UI and the data part are fully decoupled. That means, UI and data parts can be developed independently by different dedicated teams, ensuring speed parallel development. Task creation may be done from other screens also. So, our use cases can be reused. Tasks-related actions can be organized in tasks entity. Tasks repository will abstract the sources. This way, each and every component is decoupled from each other and can be developed or switched at any time to meet business requirements, ensuring no broken flow or features with minimum resources. This is just an introduction to clean architecture, and why we should use this in application development. You may have to follow the Clean Architecture Guidelines by Uncle Bob, and find a way of proper implementation of this for your project. Thanks for watching.